She's in my 6th period study hall, but not in my All right, here we go, folks. So we're actually going to start something new today. But before we do that, I want to remind you of what we've been doing for the past 3 days. So take a look at these 3 problems. If you remember, I've taught you how to do 2 problems so far. I've taught you how to do a multiplication problem, and I've taught you how to do an outside power problem. Take a look at number 1. Which type is it? Does everybody see the outside power? Okay, what do we do with coefficients and the outside power? Raise them up. So this will be -9 to that 3rd power. What do we do with exponents on an outside power? We multiply them. So what does this e have on it right now? A 1. So 1 times that outside 3 makes 3. What about your f's? And what about your g's? How's everybody doing? Now your calculator should be able to tell you what -9 to the 3rd power is. How does everybody feel about that number, okay? Calculators are working just fine. So that would be your final answer. Good? Questions? No? Okay, take a look at number 2. What type of a problem is number 2? That's just a multiplication problem. Does everybody agree that there's no outside power on either of those parentheses? Okay, so what do we do with the coefficients? You multiply them, you times them, and what do you get? Okay, what do we do with our exponents? Add them. How many a's would you get? 7. How many b's would you get? Okay, so that would look like that. Is this all okay for you, right? Okay. What type of a problem is number 3? It's both. You do have the outside power, but then I have to multiply it by that one. So this is one of those combo problems. Which part do I do first? Outside power comes first. So here we go. What am I going to do with this coefficient of -3? To the 2nd power. So -3 to the 2nd. What are you going to do with your exponent on that r? So that'll be r to the 8th. Remember, we're multiplying times this outside power here, Tyler. And then how about the s's? Wonderful. Now, what is -3 squared? Is everybody okay with that being 9? You have to put it in parentheses or you're not going to get the right number of 9. Did that other parentheses have an outside power? It did not. So we're just going to drop it down right next to it. Yes, ma'am. It is not. Make sure you put it in parentheses when you type it in your calculator. Okay. Is that okay? So that's why it's got a negative. Okay. Because what that means, Sarah, is -3 times -3. So those 2 negatives will cancel and make it a positive. Okay. Folks, this is now a multiplication problem. What are we going to do with the coefficients? We're going to multiply them. And what do you got? 2. What are you going to do with your r's? Which gives you, and the s's. Okay, so is everybody staying with Savannah here? She's rolling me along here. Everybody's okay? We're good? Good over here? Okay. So basically today, we're going to do the opposite of what we did the past 3 days. These are all multiplication problems, right? So look down at the bottom there. What kind of problems are we doing today? Division. You all see those fraction bars? And you know fraction bars mean to divide. Okay. Before we get to that, let's just regurgitate everything that we've done the past 3 days. You should certainly know by now what a monomial is. Everybody good? We've written this 3 times now. Okay. What part of monomial means 1? Mono. Doing okay? You only got a couple more minutes. Can you stay with me a couple more minutes? Okay. All right. So the first type of problem we talked about was when multiplying 2 or more monomials. What do you do with the coefficients? You multiply them. What do you do with the exponents? Add them. Everybody all right with that? Next, we had the outside power problems. What did we call those things inside, like in here? Those are monomials in there. It's all right. These are when a monomial, one term, is raised to an outside power. Okay, remind me, what part of that monomial do we raise up? The coefficient. The coefficient is the part that we raise up. What do we do with the other exponents? Multiply them. And what kind of bases are those exponents normally on? Okay, so let me go back here. This problem was an outside power problem, right? What part of this did I multiply the exponents on? Okay, so like that 3 got multiplied by that 3? But what kind of a base did it have? What is this thing called? Variable. Yeah. On the variable basis. Okay, so since I told you we're doing division, which is the opposite of multiplication, don't you think we should just be doing the opposite of everything we've been doing? Well, hold on. When dividing two or more monomials. Now, in a multiplication problem, we multiply the coefficients, right? So what do you think we're going to do in a division problem? Divide them. Now, do things always divide nice and neat? No. So if they don't divide, you're going to reduce. If they don't divide, you're going to reduce. And then we added during a multiplication problem. So what are we going to do on the division problems? We're going to subtract. Folks, when we subtract, do we always get positive answers? No. So you cannot have negative exponents. You can't have them, period. So what happens if we get a negative exponent? We're actually going to fix it. You will get it and you won't be wrong, but we're going to fix it. You're going to end up moving them to the other side of the fraction. Meaning if it's in the top, where am I going to move it to? The bottom. And if it's in the bottom, where am I going to move it to? The top. Now, this part right here that we just filled in with the negative exponents, we're going to do that tomorrow, okay? But I just kind of wanted to plant the seed so you guys can kind of be thinking about it, okay? Is that all right? Okay, now I know you guys have another blank right there, correct? Okay, we're going to fill in that blank right now. Any blank to the blank power is 1. Any base to the 0 power is 1. And I'm going to prove it to you. Grab your calculator and put in any number your little heart desires. Any number you want. And then raise it up to the 0 power and press equals. Sorry. What do you get? You get 1. It doesn't matter what the number is. It doesn't matter what the variable is. Anything to the 0 power is 1. Is that okay for everybody? All right, let's try some. So here we go. Take a look at number 1. Do you all see how it's a division problem? Do we have any coefficients? We don't have any numbers in front, do we? Just variables. So what are we going to do with those exponents? What did we just write down? Subtract the exponents on like basis. So if we subtract 15 and 9, we get 6. It is d to the 6th. That's it. Number 2. Do you have any coefficients? You do not. So what are you going to do with your g's? What do you get? This will be g squared because remember this little g has a 1 on it. So when we subtract them, we get 2. How about your h's? You'll get 3. Can we handle this okay? Now, if you give me your attention before, because you're probably like, oh, this is easy, I can do this, right? Okay, just give me your attention for a minute. Where are these? If